Let's talk about some trig functions of what are called double angles. So trig functions of double angles. The first one I want to do is the sine, and I'm just going to say of 2 theta. Use theta as my angle. Well, you might notice that's the same thing as the sine of theta plus, or sine of theta plus theta. I haven't done the whole thing yet. When we have an addition of angles, there's a formula for that, an identity. It is the sine of the first one times the cosine of the second one plus the sine of the second value times the cosine of the first value. Well, notice those are the same, so guess what? It's equal to 2 times the sine of theta cosine of theta. The second one has to do with cosine. Cosine of 2 theta is equal to the cosine of theta plus theta, and that is the cosine of theta times the cosine of theta minus the sine of theta from the addition and subtraction of 2 angles formulas. Well, notice this is cosine over here. It's cosine squared of theta minus sine squared of theta. Now the thing about cosine is a lot of people use different versions of this one. You might remember that sine squared plus cosine squared equals 1. So if we've got sine squared plus cosine squared equals 1, sine squared of theta plus cosine squared of theta equals 1, then if we want to solve for cosine, we subtract sine over, and we've got cosine squared of theta is 1 minus sine squared of theta. So I'll put that in place of cosine squared. So I've got 1 minus sine squared of theta, and then minus sine squared of theta. So 1 minus 2 sine squared of theta. So that's another version. Now there's another one that's often used, and that one is similar to this too. You might notice that the sine squared of theta is equal to 1 minus the cosine squared of theta. So if I put this stuff in for sine, in this one, I've got this. I've got cosine squared of theta minus, and then I've got 1 minus cosine squared of theta. Watch out for the algebra there, minus, minus. Cosine squared minus 1 minus minus cosine squared. So 2 cosine squared of theta minus 1. So that's the third version that people use a lot. Now if we have the tangent of 2 theta, it's equal to the tangent of theta plus theta, and that is the tangent of theta, I'm using the sum of angles formula, plus the tangent of theta. It's divided by 1 minus the tangent of theta times the tangent of theta. Well, this is 2 times the tangent of theta. Tangent plus tangent is 2 of them. And then this is 1 minus the tangent squared of theta. Now again, there are a lot of options for this. This is probably the most common, not too big a deal. So we've got one for sine of a double angle. We've got one for cosine of a double angle. Actually, we've got 3 of them, 1, 2, 3. And then we've got one for the tangent of a double angle. Well, let's see how this works. You probably remember that the cosine of 60 is equal to 1/2. So the cosine of 60 degrees equals 1/2. Well, let's prove that out. Now, this is not something you'd probably want to do on a general basis, because if you have this memorized, you don't need to. But let's look at this as the cosine of 2 times 30 degrees. That's what 60 degrees is equal to. If I use the cosine of a double angle, then I can use this one, or this one, okay? So let me use this one because the sine of 30 degrees is kind of nice. So we can say that this is equal to this identity. It's equal to 1 minus 2 times the sine squared of 30 degrees. That's the angle that we're talking about. Okay, so what is the sine of 30? Well, the sine of 30 is 1/2. Sine of 30 degrees equals 1/2. So I'm going to put that in here. So I've got 1 minus 2 times, and I've got 1/2, but I've got it squared because it's sine squared. So I've got 1 minus 2 times 1/2 squared is 1/4. 2 times 1/4 is 1/2, so that's 1 minus 1/2. This equals 1/2. Now, if you had this memorized, you didn't need this, but notice how those work. So it's kind of a nice situation. If you need to do this in general, you know, you've got some kind of a value, sometimes it makes things a lot easier. So those are some trig functions of double angles.